Hello everyone. So today we're going to go over section 6.0a, adding and subtracting fractions. We'll begin by looking at pattern blocks, with which we'll learn to write fractions using common denominators. So a, a single yellow hexagon represents 1. So this is equal to 1. And one triangle represents 1 over 6. Okay, and when we have 6 of these triangles, they combine to make one yellow hexagon. Likewise, each one of these red trapezoid represents 1/2. And we can see that 2 of them combine to make a single hexagon, which represents 1. And finally, the blue parallelograms represent 1/3. And when we have 3 of them combined together, they make 1 hexagon. Okay. So, a couple of review and prerequisites. Number one, when we're comparing fractions, as we have here, if they have the same denominator, then we're looking at the numerator of each one. And 2 is a greater numerator than 1, so 2/3 is greater than 1/3. Okay. In the second case, we have the same numerator. However, the denominators are different. We have 1/3 compared to 1/2. Okay. And as we can see here, if we have 1/3, it is less than 1/2. We can also see this with the pattern blocks example from above, right here. And we can see that 1/3, the blue parallelogram, is smaller than 1/2, which is represented by the red trapezoid. So, next question, can the numerator be greater than the denominator? The answer is yes there. And the question then is, what does 3 over 2 mean? This is, of course, an improper fraction. And 3 over 2 is equal to, well, there's 1 and then 1/2. Can we have negative fraction? The answer there is also yes. What does it mean? Well, let's say, for example, if we have negative 1/2, similar to what we learned with the integers, negative 1/2 means instead of moving to the right of 0, we move to the left of 0 by half a space. Okay. Now, next up we have some equivalent fractions. So we are going to be looking at 1 over 1, 2/3, 1/2, and 1/3. Let's going to rewrite this here. Okay, that's better. Okay, so instead of 1 over 1, what we can do here is we can divide this one hexagon into 6 equal triangles, like so. So 1 over 1 is equal to 6 over 6, for example. Second example, we have 2/3. So let's go ahead and draw 2/3 first. This is what it would look like. Here's 1/3, 2/3. Right. Top left and bottom left are 1/3 each. So together we have 2/3 to the left-hand side. And if we divide each one of those into two parts, we actually have 4 out of 6 parts completed. So 2/3 is the same as 4/6. Okay, next up we have 1/2. So let's gonna look at the bottom half perhaps of the hexagon, and in this case we can divide the bottom half of the hexagon into 3 triangles. So 1/2 is equal to 3/6. And finally, if we have 1/3, so just one corner in the bottom left here is 1/3, and we can divide it into two parts. So this will be equal to 2/6. Okay. So another way to write the fractions to have a different denominator is to multiply both the numerator and denominator by the same number. So in the first case here, going from 2/3 to 4/6, we simply multiply both the numerator and the denominator by 2. Going from 1/2 to 3/6, we multiply both the numerator and denominator by 3. And finally, in the last example, going from 1/3 to 2/6, we multiply both parts of the fraction by 2. Okay. So next up, we're going to look at this mixed fraction here. We have 2 hexagon and 1 triangle. So this is actually going to be 2 and 1/6. Okay, and that's a mixed number or mixed fraction. Now, if we were to rewrite that as an improper fraction, then notice here we can divide both the hexagons into 6 triangles. And we have here, let's see, this is 6 triangles, so 6/6. This is another 6 triangles, so 6/6. And of course, here's 1/6. So in grand total, we have 13/6. All right. So this is a little bit of review on writing equivalent fractions. Now we're going to add fractions first by using some pattern blocks. So here we go. We have 2/3 plus 1/6 as our first question. So here we color-coded everything. So this is 1/3 and 1/3. So all together we have 2/3. Next to that we have 1/6. And if we add them together, well, we can combine them and we'll be missing this triangle here from 1. Okay, but that's not a good way to necessarily write the answer. So instead, what we can do is rewrite the 1/3 as 2/6. So instead of writing using these parallelograms, we can use triangles instead. So this is 1/6, 1/6. Oops. Right, 2/6 is 1/3, and then another 2/6 is another 1/3, plus our 1/6 here, and we get 5 1/6s. So the sum is 5/6. And that is to say that if we have 2/3 plus 1 over 6, we can instead do the following, and that is rewrite 2/3 as 4 over 6. Oops. And then add 1 over 6. And now we can add the numerators together. 4 plus 1 gives 5 over 6. Okay. Second example is fairly similar. We have 1/2 plus 1 over 6. So here we have 1/2, and then we have 1 over 6. And we can add them together. So we can see here on the right, we're missing 1/3 from 1. But instead, of course, we can write this in common denominators. So instead of 1/2, we have 3 over 6. And then we have 3 over 6 plus 1 over 6. Sorry about that. And that will be 4 over 6. However, 4 over 6 can be simplified, so we can write it as 2/3. So to write everything out on the left, here's what happens. We have 1/2 plus 1 over 6, which is 3 over 6, plus 1 over 6, which is equal to 4 over 6. And then we simplified it to be 2 over 3, or 2/3. Okay, so when adding and subtracting fractions, we need to have common denominators. That's the idea. Just going to go ahead and add and subtract here without the use of diagrams. Okay, see how this all works out. Question number 1, we have 1 over 12 plus 3/4. So we want a common denominator. In this case, it will be 12. So we have 1 over 12. And if we multiply the numerator and the denominator of 3/4 by 3, we have 9 over 12. So 1 over 12 plus 9 over 12 is 10 over 12. Notice that both 10 and 12 are divisible by 2. So we can simplify the result to be 5 over 6. Okay. Next step here, example 2b. So here, what we can do is rewrite both fractions to have a common denominator. In this case, the common denominator will be 20. So the first fraction becomes 5 and 12 over 20. The second fraction becomes just 5 over 20. And if we add them together, we have 5. And then 12 plus 5 is 17 over 20. Okay. Since this 5 here represents 5 ones, so after we add, it's still going to be the same 5. The fraction part is the second part here, 12 over 20 plus 5 over 20, which is 17 over 20. Okay, let's continue. The next one, in this case, the common denominator is going to be 15. So we have 2 and 12 over 15. And in order to get a denominator of 15, we multiply both the numerator and denominator by 3. So those will be plus 4 and then 6 over 15. So once we add those together, 2 plus 4 is 6, and then 12 plus 6 is 18 over 15. Now, notice that the 18 over 15 is an improper fraction, so we need to rewrite that as a proper fraction since it is a part of a mixed number. But before we do that, we can also simplify the fraction first. So notice that both 18 and 15 are divisible by 3. So we can simplify the fraction first, and this will give us 6 and then 6 over 5. Okay, and the idea here is that 6 over 5 is equal to 1 and 1/5. Okay, so we have 6 plus 1, which makes 7, and then still the 1/5. Okay, moving on. Next question here. This common denominator, we're going to use 18. 9 times 2 is 18, and 6 times 3 is 18. So that would be a common denominator that we can use. So this will give us 14 over 18. That's the first fraction. And the second fraction, instead of 1 over 6, we'll have 3 over 18. And from there, we can just subtract. 14 minus 3 is 11. And this will be all over 18. Okay, it's a couple more. This next one is interesting. We have a whole number, a 9, and then minus 3 and 2/7. So one way to do this is to rewrite one of the 9 whole numbers as a fraction. So that what I mean is, instead of 9, we can have 8 and 7/7 minus 3 and 2/7. So this way we can subtract pretty much directly. 8 minus 3 is 5, 7 minus 2 is 5, and of course the denominator is still 7. Okay. Alternatively, this question can also be done by rewriting both fraction as improper fractions out of 7. Okay, but we will do that with the next question just to see what it's like instead. All right, so here what we can do is rewrite both mixed numbers as improper fraction. So in order to rewrite the 8 and 2/7 as an improper fraction, we take 8 multiplied by 7, which gives us 56, plus 2 is 58. So this is really 58 out of 7, the first fraction. And second fraction, we take 3 times 5, which is 15, plus 4 is 19, and this will be over 5. Okay, so now we find the lowest common denominator, which is going to be 35. The first fraction, we're going to multiply by 5 in both the numerator and denominator. And the second fraction will be multiplied by 7, once again, to both the numerator and the denominator. So the numbers are going to get a little bit bigger than in previous examples. 58 times 5 is 290, for example. And 7 times 5 is 35. And now we subtract. 19 times 7 is, let's see here, 133. Right, and then this will be over 35 as well. And now we can subtract, which gives us, let's see here, 157 over 35, which will finally rewrite as a mixed number. So here we can divide 157 by 35, which will give us 4 and a remainder of 17 out of 35. Okay. So there is a couple of different ways of subtracting fractions that we looked at today, and also adding fractions before that. And that's it for today, so thank you for listening.